What if you could tackle pain not with a pill, but with a patch? A patch with zero drugs, no batteries, one that works by tapping into your body's own electrical system. Well, today we're going to look at a pretty revolutionary approach to pain management that uses nanotechnology to do exactly that. So, here's our game plan. We'll start with the problem of pain, which we all know. Then we'll check out this drug-free alternative, actually look inside the patch, and explore the wild theories about how it works. After that, we'll see what the studies say, and finally, think about what this means for the future of pain relief. All right, let's start on common ground: pain. Whether it's a sprained ankle or something more chronic, dealing with it is a massive challenge, something pretty much everyone on the planet has to face. And that leads to this huge question. For so long, the answer has just been take a pill. But we're now more aware than ever of the serious downsides and dangers that can come with that approach. So we have to ask, is there a better way? This number, it's tough to look at. This is how many people died from opioid overdoses just in the United States in 2022. It's just a brutal reminder of why the search for safer, non-addictive ways to manage pain isn't just important, it's incredibly urgent. Well, this crisis has pushed science to look for a totally different kind of solution. And that brings us to the world of bioelectronics, a field that wants to work with our body's natural wiring instead of just putting chemicals into it. Okay, so imagine this, a simple patch. You just stick it on. It has absolutely no drugs or weird herbs. It doesn't need batteries or plugging in. And get this, you can reuse it for over a year. It's a whole different way of thinking, right? It's pain relief based on physics, not pharmacology.
So what is actually going on inside this thing? I mean, it looks pretty simple from the outside, but the tech packed inside is seriously advanced. Let's peel back the curtain.
The secret sauce is something called neuro-capacitive coupling. Now that sounds complicated, but here's the basic idea. Your body is constantly generating its own tiny electrical field. This patch is designed to work with that field, kind of like a tuning fork, to influence your body's electrical signals without needing any power of its own. Think of the patch as a high-tech sandwich. You've got two flexible outer layers, right? But the magic is in the middle. It's a core packed with billions of tiny nanoparticles of things like silver and copper. And here's the key. They're arranged to be incredibly close, but they never actually touch. This setup creates a huge array of microscopic energy storage units, or capacitors. And using it couldn't be simpler. You literally just stick it on or near where you feel the pain. People who use it say they sometimes move it around a little bit to find the perfect sweet spot for relief. Okay, so this is where it gets really fascinating. How does a patch with no power source actually do anything? Well, the exact science is still being explored, but there are a couple of leading theories. First, you gotta understand that when you get injured, it's not just a physical thing, it's also an electrical thing. Your healthy tissue has a nice, stable electrical balance. But when cells get damaged, that balance gets thrown way off. It creates a kind of electrical static that triggers inflammation and tells your nerves to send pain signals. So how does the patch fix this? Well, the first theory, the capacitor model, says the patch basically acts like an electrical sponge. It soaks up all that excess chaotic energy from the injury, which helps restore balance and calm things down. The second idea is the bioantenna model. This theory suggests the patch acts more like an off-ramp for the pain signal itself. It absorbs the energy of the nerve signal as it's zipping towards your brain, effectively turning down the volume on pain. So the theories are pretty cool, right? But this is science, so we have to ask, is there any proof? What does the data actually say? Let's take a look at some of the early clinical results. In one pilot study on people with muscle and joint pain, participants said they felt, on average, a nearly 60% reduction in their pain. Now, that is a huge deal. That's the kind of relief that can take someone from being stuck on the couch to actually living their life again. But here's where my jaw really dropped. In that same study, the people who were taking opioids when they started, they reported a 91.4% decrease in their opioid use during the trial. That's massive. And this highlights the potential for something like surgery. In another study, patients who'd had knee or hip replacements and used the patch ended up asking for 52% fewer opioid refills after they went home. That's a really significant number. So these early results are, without a doubt, really exciting. But, with any brand new technology, the scientific community is and absolutely should be looking at it very, very closely. It's so tempting to think that, isn't it? But the real story is a little more complicated. we're really just at the beginning of understanding this stuff. You see, this is just how good science works. We need more research. Scientists are still debating the exact way this works on a biological level, and to really know for sure, we need bigger, more rigorous studies, the gold standard placebo-controlled trials, to confirm what these early results are showing us. But even with that need for more data, the potential is hard to ignore. As this quote from a research paper says, a lot of experts are seeing nanotechnology as a genuinely valuable tool, one that could help us dramatically reduce or maybe even get rid of our dependence on opioids after surgery. And that really leaves us with this one big final thought. For the last 100 years or so, medicine has been all about chemistry, all about drugs. But maybe, just maybe, we're on the edge of a new era, an era of bioelectronic medicine, where we finally learn to speak the body's first language, electricity.